of these behaviors. We're going to start with resonance. It is sympathetic vibration. So the vibration of a body at its natural frequency caused by a vibrating source at the same frequency. So this doesn't make any sense whatsoever. Examples are better. So this is pushing someone on a swing. You have to time it just right. Push them right at their crest each time. That's resonance. Something like this, actually. Let's see if I can do this.
Exactly. Yeah. See, they can't see us, dog.
As an example of resonance, we also have rocking a car. To get it out of the snow when it's stuck, you have to push it right at the exact same time. You're rocking back and forth, and you're matching the frequency of your previous push. Water molecules, when microwaves hit them, that's how they heat up, is when they're vibrating back and forth like that. Swirling a cup of liquid to get it to spin. And seeing glasses, which I'm going to try to get to work later during this unit, but we'll see. Okay, so in order to get pool waves large enough to splash out, you have to jump in multiple times in the same spot, and that's also resonance. So there's also reflection. That's when a wave hits a barrier and it bounces back and it has an inverted amplitude. We'll talk more in depth about reflection in a lesson or two. Then there's interference. This is when waves get superimposed when they are in the same place at the same time. They will interfere with each other. And that means that their amplitudes add, or if you add a negative going in the opposite direction, they subtract. So here we have constructive interference. If both of the amplitudes are in the same direction, a positive and a positive, so this is positive, then they add. So here's the 5, and then on top of that is the 10. You get 10 plus 5 is 15 centimeters. And the amplitudes add, so that's constructive interference. So this is what happens when two waves come together and meet right here. So you have this wave, this part of the wave going here, and this part of the wave going here, and they meet, and then they add. So they were down here. They were like this and this. So then they added so that the amplitude was much higher, much greater. Okay. Then destructive interference is when waves are out of phase. So if you have a positive and a negative, then you have destructive interference. So for here, it would be like this, and then I guess to draw it, it's kind of like this, and it's equal to 0. You can also have something like this, and like this, and it takes it away. So a better drawing is like this, and that goes away. So this was 15, this was 5, so now we have 15, 5, and that's going to be 10 centimeters. Okay, so some examples of these are noise canceling headphones. These are super helpful, useful. We love these. Yay, we love them. Okay, you can also talk about super top secret helicopters, but I'm not going to go into that. I'm just going to leave it there for you to think about. Okay, so where would you get the greatest constructive interference? What do you think? The greatest constructive interference. So the greatest constructive interference, you want the two in the same direction, that are like right on top of each other. So that would be D right here. Okay, and then the greatest destructive interference would be here when one is going up and this one's going down, and they almost cancel each other out. This is B. What will the resultant wave look like when the two waves are at the same place at the same time? So here we go up and then down. 3 minus 5. So 3 minus 5 is equal to minus 2 centimeters. Beats. Now, those of you who are in band have a distinct advantage here. Beats, you can hear this all the time when the whole band tunes the instrument. Beats are the interference between two waves that have different frequencies. At times, the waves constructively interfere and other times destructive. So there's an alternating loud and quiet sound. Slow beats means that the waves are close in frequency, so they're almost tuned. Fast beats means that they're very far apart, so you have to get them closer together until they completely disappear. So here, it's constructive. When it's a positive and a negative like that, it's destructive. Here it's constructive again. They're in the same direction, and this is destructive. So for the Doppler effect, this is the apparent change in frequency due to relative velocity between the observer and the source. As it approaches, there's a higher frequency and a shorter wavelength. And away, the frequency is lower, but it has a longer wavelength. So it's faster, there's more shifting. And you can, an example of the Doppler effect is when you have a fire engine passing you. That is when it changes frequency. That is the Doppler effect.